Hi everyone, my name is Yurii Paniv. I'm a PhD student from Ukrainian Catholic University, and together with my colleagues from Open Babylon, Lang UK, and Minerva University, we would like to present you with benchmarks for multimodal large language models for Ukrainian language. The problem is that vision language models are primarily evaluated on English-centric benchmarks, and there is a notable gap about how to evaluate vision language models in low and mid-resource languages. And there are non-existing Ukrainian multimodal benchmarks, and therefore there is no comprehensive evaluation for Ukrainian language capabilities in large language models, which leads to cultural knowledge and representation issues. Our contribution is that we introduce the ZNO-Vision, a comprehensive Ukrainian-centric benchmark based on Ukrainian school exams. It's a first evaluation of multimodal text generation for Ukrainian language. Besides that, we evaluated existing multi-30K UK benchmark for caption generation task. We created a UI cuisine benchmark for measuring cultural knowledge. Uh, for that reason, we evaluated both proprietary and open source vision language models and provided a methodology template for other low resource languages. To benefit community, we published all code and data sets with our methodology for reproducibility. Uh, uh, our ZNO-Vision dataset is based on standardized university entrance examination and data from Osvita portal. It's STEM-based. STEM categories dominate with more than half of the dataset. It covers multiple disciplines such as mathematics, physics, chemistry, and humanities. And a large portion of the dataset is visual only to simulate OCR settings to understand how good is understanding from just visual modality alone in Ukrainian language for large language models. Uh, as for additional benchmarks, we made the UI cuisine benchmark. It's a cultural benchmark which features 20 popular Ukrainian dishes. We make 7 question times across 3 categories like identification, generation, and classification. This is done for the purpose of addressing cultural misrepresentation issues and to test knowledge of national cuisine and cultural understanding. And last but not least, we take the existing dataset, multi-30K UK, from citation other researchers to measure image captioning task for Ukrainian language. As for our evaluation, we use LMMS eval framework for standardized evaluation. We follow similar split as for MMMU paradigm. We use multiple metrics accuracy for ZNO benchmark, and for free text measurement, we used a combination of BERT score and Sacre-Bleu metric to measure how close source and target texts. To promote reproducibility, we used standardized prompting across all models and frozen a setting as part for generation parameters such as temperature, token limits, and other ones, and we optimize them based on a benchmark that we measured upon. As for models evaluated, we evaluated a set of proprietary models like models from Anthropic, OpenAI, and Google. We also measured open source models like Qwen, Llama, and Gemma in range from 2 billion to 90 billion parameters. And using that, we obtained a comprehensive coverage of current state of the art to get an overview of existing capabilities of vision language models in Ukrainian setting. The only limitation of our approach is we haven't measured reasoning models in our experiments. As for the ZNO benchmark results, the leading models are proprietary ones. The top one model was a Quad Sonnet from Anthropic with Gemini models just behind them. And we found out that Qwen 2.5 and Llama 4 are the best open source models for Ukrainian multimodal setting, with Qwen 2.5 being close to proprietary GPT-4o. And as for another models, we found out that Llama 3.2 and Pixtral failed to even beat a random baseline, and as part of to exclude contamination of text parts of the tests, we measured in text-only settings the same questions and found out that it's close to a random baseline, which makes benchmark useful for measuring specifically understanding of visual modality of those questions. As for caption generation results, we found challenges with measuring that task, and our best correlated metric was BERT score, and GPT-4o achieved both the highest BERT score and BLEU score. But the difference between BERT and BLEU score we explain by stylistic differences between source and target texts. So for models to achieve a high BLEU score, a fine-tuning would be needed to achieve that goal. And as for your cuisine benchmark, Quad 3.7 performed best overall across all categories, achieving high BERT score and exact matches for recipe identification tasks and intersection match for naming ingredients in particular dishes. And among the strongest open source models, we found out that Llama 4 Maverick and Gemma 27 billion were the strongest ones as for open source models. But as we can see, there is a significant room for improvement in cultural understanding specifically. As for challenges that we found out during our measurements is inconsistent instruction following in Ukrainian across all models. It even occurred in high-performing models like GPT-4o, where we tried to explicitly tell to place answer inside quadratic braces, but still models frequently fail to do so. And for notable models like Llama 3.2, 90 billion, it responded with English letters instead of Ukrainian, which rendered incorrect results. But even with mapping English letters to Ukrainian ones, it still couldn't respond correctly still. And frequently models failed to generate short answers for the question, even if they were instructed to do so. And that's why we applied a custom format extraction rules based on patterns that we noticed in model responses. In this case, we were able to meaningfully extract responses from correct responses from models. A second challenge, a significant one, was code switching issues. Uh, uh, Frequently, models prompted in Ukrainian switched to English, Chinese, or even Russian, and frequently there were broken grammar generation, like in this case in the picture, or even non-existing words and tokenization artifacts. And from previous research, we know that similar issues occur in text-only ZNO setting, which underpins lack of Ukrainian data in large language model training. And a third challenge is cultural misattribution, and Ukrainian borscht was mislabeled as Russian red borscht, despite being UNESCO recognized Ukrainian cultural heritage. And frequently, when prompted in Ukrainian, models defaulted to English or Russian responses. Uh, Frequently, recipe generation suggested incorrect preparations, which leads us to believe that there is a systematic bias in training data, which affects cultural identity in responses. So, in conclusion, we made the first objective framework for evaluating Ukrainian multimodal capabilities. We revealed significant performance gap and cultural representation issues. During our measurements, we found out that only top-tier models achieved reasonable performance, with open source models being close ones, but still there is a lot way to go. And we see this as a critical need for inclusive AI development, especially for low and mid-resource languages. To facilitate research in that direction, we open source code and dataset, and it's all available for community use by that link. Thanks for your attention. And last but not the least, we would like to thank our sponsor. Without them, this research wouldn't be possible. We would like to thank Alex, Denovo, and Mykola Consulting for providing computational resources, Amazon Web Services, and Google Cloud Platform. Thanks for your time. Have a nice day.